Welcome to It's a Dark Matter Thing, episode 3.
Where this week we're going to be talking a bit about the James Webb Space Telescope and some different areas of space research.
So, Caitlin, what have you got today about the James Webb Telescope? It's very interesting.
Well, we did speak a little bit about this in our last episode, or was it the episode before? I lost track of time. Anyway, whichever episode we spoke about the James Webb Space Telescope, we had a few messages of people wanting us to elaborate on that. So that's what we're going to do today, I guess.
But yeah, so the James Webb Telescope is a hot topic right now, especially in astronomy, because it's getting launched in the 18th of December this year. And they've been working on it for a fair few years, from what I know. It's been a while, I think since like 2011. I'm not
Yeah, it's been a long
100%.
time.
Yeah. A lot of work's gone into it, and it's very interesting, especially where they're positioning it.
Yeah, so hopefully we can organize ourselves enough and, have our technology friends, and we'll be able to, have some sort of live stream when that's happening and we can talk about it
Yeah,
as
definitely.
it's launching.
Yeah, well, especially watching us live, watching it launch, we'll be like, "Whoa, that's so exciting!" Especially
We have to get
for
little
the
party
yeah,
poppers.
yes, that would be amazing. Done deal. It's happening now.
Yep, happening. Tune in for our live stream. That could go awfully wrong because YouTube doesn't like us.
No, YouTube, we've had a few problems with. Really does not like us, does it?
YouTube just decided it didn't want to be our friend. It doesn't want to support our podcast. That's fine, YouTube. You do you.
Yeah, but we've fought it and we're slowly winning the battle.
Okay,
Yeah,
so back
okay.
onto James. A little tangent over there. Okay, so basically the James Webb Telescope is going to be looking at longer wavelengths of light than Hubble does with greater sensitivity. So it's going to be looking at infrared wavelengths. So that it can look further back in time. So basically, when it's looking at these longer wavelengths, it's able to look back in time. And this is because as the light is traveling from wherever it's coming from, these wavelengths, it's getting redshifted. So if we look at a spectrum of light, so it goes gamma rays, X-rays, ultraviolet light, visible, near-infrared, infrared microwaves, and radio waves. So if something is produced in ultraviolet and these wavelengths are coming towards us from really far away and they're getting redshifted, it's going to be moving more and more towards the infrared
Yeah, so it's getting
wavelengths.
stretched, hey. It's like the
Yeah.
wavelengths like getting pulled, and it's the spaces between the fringes are just getting further and further apart and like sort of moving
Yeah,
away.
so they're getting longer, these wavelengths. And so
Yeah.
that's why they're using this infrared technology, or looking at the infrared wavelengths to look at things that are further back in time, because whatever light they're producing, it's going to get redshifted and it's going to be a lot easier to detect
Yeah.
these infrared wavelengths.
The way that the universe is sort of set out, it's like a web. So you've got these clumps of galaxies, and I think we've sort of talked about this as well. So you've got those clumps
Yeah.
of galaxies and then these voids. And in the voids, you've got dark energy and it's stretching space and time. So when you look further and further back, the light's moving through more and more voids as well. And this is also causing it to get stretched, making it very, very hard to detect on Earth. So when you hear about a lot of astrophysicists talking about the universe that we can see, it's due to that inability to see those really long wavelengths that Caitlin's talking about.
Yeah, definitely.
Yeah.
And the reason why they have these telescopes up in space, you might be thinking, what's the point of blasting them off into space? It's actually because our atmosphere, Earth's atmosphere, interferes with what we can see. So our telescopes down here on Earth, while they can still see a lot, they can't see as much or as clearly as space telescopes because the atmosphere is interfering with it. If you think about, if you go outside at nighttime and then it's all cloudy, you can't see any of the sky, so that's really useless for our telescopes here.
Yeah, and as much as we can see the night sky when it's a clear night with telescopes and sensitive gear, the atmosphere is just really, really,
Opaque.
yeah, like it just has a lot of interference going on. All those oxygen and hydrogen atoms are just,
Making the telescope's life difficult. So we
yeah.
blast off into space and say goodbye. Why do we care about the James Webb Telescope? Why is looking at these, what are they? These infrared wavelengths so important and such a huge thing for astronomers right now? Well, that
And we
is,
should probably state as well that there's been no other telescope nearly even close to what the James Webb Telescope is going to be able to see
yeah, definitely.
like,
Yeah,
at all. So it's going to see very
it's
far.
going to be really cool. So what its whole aim is to observe galaxies formed in these really early stages of the formation of the universe. So like what we were talking
Mm.
about last week, we can see these galaxies, but it's really hard for us to actually observe them because when we look at them, we're just seeing quasars, which are really bright black holes in the center of them. And so if you think about it, it's sort of blocking out everything else. We can't actually see the light from anything else because they're so bright in the center. We just see a
Mm.
bright little blob.
And there's
But
still so many questions about galaxy formations. We
yeah,
really
definitely.
don't know a lot about how these spiral galaxies get the way they do. And especially, yeah, as you look further back in time, there's so many more quasars than there are in our universe close to us. And that's a question, why? Why are these quasars everywhere in the early universe?
Yeah, so
Mm.
obviously observing these galaxies and how they formed is going to answer a lot of questions about how did these supermassive black holes even get to the center of the galaxies? Were the galaxies formed because of black holes, or is it the other way around? So definitely it's going to answer a heap of questions that we have about the formation of galaxies. And obviously galaxies take such an enormously long amount of time to form and actually, look like a galaxy that we can't observe that happening in our time because
Mm.
we'll all die by the time the galaxies even started forming. Um,
Yeah, and the strangest thing about galaxies is that, we live in a universe where organization is unnatural.
yeah,
So for things to be so organized and put together, it's not a natural thing. As you'd probably, like, if you put metal out and leave it there for years, it actually disintegrates and becomes less organized than it was to begin with. So at some point, somehow, all these stars and dust and galaxies have just formed into a really organized matter, and no one really understands how that could possibly happen. So the further back we look, we're going to see those key elements to how all this organization has happened in the first place, which is
yeah,
really cool.
we can look at like the different galaxies in different stages of their formation and evolution
Mm.
as well, which will help to sort of piece together a sort of timeline of how galaxies form and how they change over time.
Yeah, no, exactly. And in hand with the Hubble telescope, they know where they want to point the Webb telescope, where to look, which is awesome. They've already
Yeah.
got half of the research out of the way, so it's going to be very interesting.
Yeah, that's
Yeah,
going to be some really cool data coming back. So
yeah.
the other things that are the primary goals of the James Webb Telescope is looking at star and planet formation inside of uh, gas and dust clouds. Now, if we look at gas and dust clouds, stars and planets form inside these big clouds of gas and dust. And obviously, if we're looking at the gas and dust just normally, we can't see these planets and stars forming because all the other gas and dust is in the way. It's blocking out our view.
And
So,
these planets are not flat due to how gravity in those clouds collapse in themselves. I'm just going to make that clear to anyone wondering about the worlds being flat in our universe. Just
no,
making it clear.
they're not flat. So they're forming
Oh.
round planets and round stars. And yeah, obviously the gas and dust is in the way and we can't see what's happening, so that's pretty useless to us. But again, using this infrared uh, waves, we can actually bypass all that gas and dust and actually see what's happening or get data on what's happening and look at how these things form in there. And one of the things that's really important about this is we're looking for other planets that could be like Earth, that could be forming like Earth and could be habitable. So basically, Earth's temperature emits most of their radiation in these infrared wavelengths. That's why we're using it to look for Earth-like planets, because if it's like Earth, it's also going to be emitting
because
infrared radiation.
And for people who don't know much about wavelengths and how it all works, to emit ultraviolet wavelengths, you have to have a lot of energy. So that's why you see it in a lot of radioactive situations. So when you've got atmosphere and really stable elements going on, they're not going to be emitting those really strong wavelengths. They're going to be emitting these really, really nice, small ones, weak ones. Yeah. Well, also should mention where the James Webb is going to be located, because it's very different to all of our other It is very different to all of our other telescopes where they're orbiting around Earth. If anyone knows about the Trojan points around Jupiter, it's a bit like that. So they're positioning the James Webb telescope in a stable area of gravity. So it's going to be on the outside of the Earth from, I can't really explain it without a picture. So you've got the Earth, you've got the sun, and the James Webb telescope is going to be on the other side of the Earth. And it's going to be in a position where it won't be orbiting anything. It'll be actually orbiting around the sun with the Earth. But because it's in that stable position of gravity from the pull of Earth and the pull of sun, it will be orbiting at the exact same speed of the Earth, which is very interesting. And this will make it easier to be receiving data from it at quicker times, because it won't be on the other side of the sun, or it won't be thousands of kilometers away. It's still going to be relatively close, but orbiting the sun, not the Earth. So it's really interesting what they're doing. Also,
it's
giving
like
it
in a little sweet spot of gravity.
Imagine in a gravity, like as a hill in our gravity grid we talked about.
We
It's sitting on top of that. Yeah, it's sitting on top of that hill. It's not falling. It's not doing anything. It's just on this top of the hill. On this side, we'll obviously be posting pictures of these points to make it a bit more understanding, because it is a visual concept more than an explanation concept. But the main thing to take away from it is that the James Webb telescope will be orbiting the sun and not the Earth, and it's doing it it's further away from the sun than the Earth is, but at a spot that it will be orbiting at the same speed as the Earth will be, which is awesome.
Yeah. So another thing that the James Webb Telescope will help us to look more at is the history of the acceleration of the universe. So last week when we were talking a bit about dark matter, we talked about the different models of the universe and how the universe was changing due to its acceleration as well as the critical density. So by looking at
honestly, I think that is a pretty good sum up of what the James Webb telescope's going to do. It's going to do a lot, and it's going to help with a lot of research about the beginning of the universe and the weird things that may have occurred for it to be the way it is. Yeah.
Yes. So, will we talk about some of the Australian research, I guess, as well?
Yeah.
So obviously we've also discussed a lot about research that's happening outside of Australia, but there's also some really cool research that's happening with Australia right now, and Australia's really starting to ramp up and start collaborating more and becoming really more active in the space industry in these last couple of years, which is really exciting as well.
Yeah.
Because
definitely.
they weren't really that interested for a while. It was sort of just lingering, but now, they're definitely getting some more hands-on collaborative work with some of these other places like NASA and ESA and stuff.
Yeah, well, one of my favorite things to do is just go onto Google and look up astronomy jobs in Australia. And
There's like
some of
two.
actually, no, the other day I looked it up and there was like 36 different jobs hiring, and it was all research jobs with university, which is awesome. But there was some really cool stuff out there. There was looking for pulsars, there was even looking at dark energy, galaxy formations, and it was all over Australia from Tasmania to Perth to Sydney. And I was like, wow, that is so cool. In Australia, they're doing this.
Yeah, Australia's getting into some really different
Yeah.
research as well, which is really cool. They're not sort of branching out into, what everyone else is doing. They're sort of branching more into their own little
Yeah,
thing, which is
definitely.
of different astronomy, which is really cool. So last week we talked how Australia was participating in research into dark matter. Taylor spoke
Mm,
a little bit about that, which was really interesting. But the other day, I think it was last week, there was some new information released about gravitational waves that Australia has
yes.
been researching.
I
So,
did see that come up as well. They're hiring for that as well. Isn't that awesome?
Taylor's gonna get a job
I know.
looking at
I'm like,
gravitational
I'm
waves.
excited. I'm excited because I'm going into this astronomy industry, and so are you, Caitlin. And everyone goes to me, "What job are you even going to get with that?" And I'm like, "Cool jobs, really cool jobs."
We're gonna be cool
Yeah, we're gonna be cool. We're gonna be doing cool stuff, looking at cool nerdy things. Like seriously, guys.
all day. Don't worry, we are planning on doing a whole episode about jobs and careers related to
Mm.
space and what we're going to be doing, so stay tuned for that one. Back to
Okay.
gravitational waves though.
Does
So what
anyone notice
actually
that we get very distracted?
I feel like already we've been on about 5 tangents about completely unrelated things.
It's okay. It's okay.
Okay,
I'm
actually
sure
back to
they're
gravitational
interested. I
waves.
hope they are.
I'm sure they're not clicking off. It's okay. We can see what time you click off. It's fine. We don't care.
Yeah, it's a bit rude, guys. No, I'm just
Please don't
kidding.
click off.
You're all listening all the way to the end, and it's great to see. Thank
You
you.
all go read our Instagram posts as well
Yeah,
to look at pictures because that's what we like doing, looking at pictures.
yeah,
Okay,
yeah.
back
Okay.
to gravitational waves. So, gravitational waves, what actually are they? So, back to our best friend Einstein and his theory of general relativity, and we talked a bit about space-time, and obviously the grid formation. And so space-time can actually be warped into black holes. And so as these accelerating masses are moving and doing things, they're creating ripples in space-time. So if we think back to our grid, if it was like a swimming pool and you were bouncing around in the swimming pool, you'd be creating little waves. So that's what's happening with the black holes. As these really massive objects are moving and they're interacting with each other, they're creating ripples, and that's what the gravitational waves are, ripples in space-time. And that's what Australia is detecting. So it's something called Ozgrav. If you want to look it up, they have a website. They're also on Instagram and they post all their research there. So they're looking into these gravitational waves. So the first gravitational wave was detected in 2015, and it was a really, really big thing because before that,
Yeah,
obviously,
it was very exciting. I remember it.
yeah,
It was.
yeah, it was a
Mm,
huge thing because obviously, before that it was just a theory that Einstein had said and there wasn't really any solid evidence for it and there wasn't, no one had detected it before. So
and
it's
to be fair, it was very hard to detect. Like they had to have a very sensitive instrument,
yeah,
from
it,
what I
it was a
gathered.
lot of
Yeah.
work.
Yeah.
But these are important because they can be used to give us more information on black hole and neutron star mergers and to understand more about how they evolve and form and things like that. So basically,
Mm.
the research that Ozgrav put out last week or whenever it was that they'd found a heap more of these gravitational waves from black hole mergers and neutron star mergers. So when these two objects come together, it's sort of like when galaxies are merging and other things, if you think about it, they're sort of fighting for dominance. The one doesn't want to give in to the other, and it's like, no, please don't suck me
Mm.
into your black hole.
Yeah, and they like pull at each other, and it's just
Yeah,
messy. They just are
there's
like, "Ugh."
There's a
No.
heap of simulations online as well. I love watching them. It's like, an
Mm,
epic battle of who's going to be the bigger
yeah.
black hole. And so as all this is happening, they're obviously creating these ripples in the space-time. You think if you're in a swimming pool and you're fighting with your friends, there's obviously lots and lots of waves happening. So that's what
Mm,
is being detected, these waves that are sort of like the leftovers of the epic battle that went down with the black hole. And obviously we can't see the two black holes anymore because they've merged into one. Um, but yeah, so it's the remnants of this battle, and then we can use that information to learn more about black holes and neutron stars.
yeah, very interesting stuff. Go Australia.
Woo! Claps for
Woo!
Australia. Love that for them.
Mm.
And also there was NASA launching rockets from Australia as well. Come on.
Yeah. Well, I'm a Darwin girl, and they obviously have put their base up in Arnhem Land, NT, and it was getting talked about for a few years, on the grapevine. Oh yeah, they're gonna send rocket ships up from Arnhem Land, and everyone's like, no way. And it was talked about for a while, and obviously Darwin's a pretty small town, and there's a lot of business between Arnhem Land and Darwin. So when they were actually clearing the land, it was, everyone in Darwin was talking, oh my God, they're about to build the launch pad. And then it was very hush hush. We didn't hear about it for ages. And then all of a sudden they released that it was happening.
Yes, that's
So it
also
was,
really exciting
yeah,
because NASA's actually never commercially had a rocket launch from anywhere else. So, go
yeah.
Australia, number one.
And you're probably wondering why the NT, why Australia? And it's got to do with the NT being very nice and close to the equator. So the closer to the equator you are, the easier it is to launch a rocket using the Earth's spin. So yeah, the Northern Territory was a prime location, especially Arnhem Land. There's only a small town there, and it's far away from people enough that it's not going to do too much disturbance. There's been a lot of talks about northern Queensland as well, but Queensland's much more populated than the NT, so I think they've chosen a nice spot, and hopefully it brings in a lot more work for everyone in the NT as well because they deserve it.
So that's really, really awesome for
Yeah,
the NT out there. So yeah, that's really cool that Australia is getting on board with this and, working with NASA and ESA who have, been these big space superpowers for such a long time, and
yeah,
Australia sort of just sat back. But really, we are in such a prime position for astronomy here. From our location on the Earth, we can see so much of the sky. Um, to also, like launching the rockets and stuff, we're in a really, really good position. So it was really disappointing for such a long time that Australia was just, sort of sitting back and neglecting the space industry. But I think a lot more people are starting to get excited about it, and it's becoming
and
a
definitely and
really big thing.
educated.
So obviously speaking with about all this research and all this stuff, obviously it does cost a lot of money and a lot of it is government funded. And obviously, we've seen with American stuff, um, when the government decides to cut the funding to space, a lot of other things start to suffer as well. And,
Yeah,
if we look back and we look at some of the technology that we use every day, like the Wi-Fi that you're using and the phones that you're using to listen to our podcast right now, were all sort of created because of space. Wi-Fi, for one. Um, Cameras in phones were also created to go on rockets, so we wouldn't even have cameras in our phones like we have now, if it
yeah.
wasn't for developing space industry. Another
Mm.
really interesting one that I found while I was looking at this is the jaws of life that they use to cut people out of car accidents. Uh, were actually invented as a way to separate devices on space shuttles.
Oh,
So another
wow. I
thing,
don't even know
yeah,
that. That's so
yeah, no, neither did
interesting.
I.
And when I went to the Australian Space Agency down in Adelaide, they talked about this really cool device that they put on cows now. And it's like a collar, but it's almost like a fence line.
Oh, yeah, I
So
heard about that.
yeah, so they use the satellites to map the area, and they connect it up to this collar. And it's like a virtual fence. So when these cows are walking up to these fences, they get a little zap that just, and it doesn't hurt them, but it just sort of steers them away from going to that area.
Yeah.
And what this has done for farmers is save them a lot and a lot of money on repairing fences, doing fences, building them, the materials, all of that is involved. And especially with Australian weather. Australian weather is
Yeah.
notorious for absolutely destroying farm areas. So it's very
Yeah,
exciting
that's for sure.
technology for even agriculture.
Yeah, so this space industry doesn't just benefit one industry. It's like sort of a
Yeah.
flow-on effect because then they integrate these technologies can be used in everywhere.
Yeah.
Baby formula is another one as well.
No, it's very interesting. And a lot of people, when they hear space industry, they instantly think, oh, Elon Musk and all of those people, using it to go to Mars. But it's really not
Yeah,
there. That is probably 2% of the space industry and how much the
yeah,
space industry contributes to on life on Earth.
yeah,
Yeah.
definitely. And I think a lot of agriculture is now also getting
Mm.
into using more of space technology as well,
Yeah,
which I
same with
think is really great.
yeah, so self-driving tractors.
Oh,
I
yeah.
have seen as well use satellite data.
Yep.
Yeah.
Yeah,
And
the
as well as
GPS.
that, a lot of people go, oh, the space industry is so bad for the environment. But without those satellites up there, data on how the environment is doing, the atmosphere, climate change, we wouldn't be
Like
getting it.
weather,
Yeah,
like
weather.
weather predictions,
Yeah.
you wouldn't be able to get on your phone and look up
So,
what's the weather's going to be today.
yeah, no, definitely. So, as much as you may feel that the space industry is really bad for the environment at the moment, and not be wrong, like rocket mission is pretty full on. But as well as that, what they're putting up there can be what it helps us save the earth from climate change, because unfortunately it's not something talked about as much as it should be, but the government's starting to get a bit more on board with climate change and
Mm.
um, our planet. So, it's not as bad as I think everyone should put it. It's a
Yeah.
double-ended sword, really. It's one of those situations where, as much as it can hurt, it can help, just like anything, you know.
Yeah, so that's why it's really exciting that Australia's sort of getting more
Yeah.
on board with this space industry and, starting to develop stuff and definitely going down a more unique pathway than what others are researching is
Mm,
definitely going to help, sort of get Australia on the map in a way. And, who knows what technology is going to come out of this that could, be the next thing that we can't live without.
exactly, exactly. So we're going to have a little discussion about STEM careers, a little bit about the schooling system at the moment, because both Caitlin and I have a pretty strong opinion about it all.
To sum it all up, we think school is a bit rubbish in educating kids about STEM and careers in STEM. Obviously, we're both going into careers in STEM, but for me, when I was looking at it, it was probably one of the most secure jobs in the future. And if you saw, we put it on our Instagram stories, the Australian Space Agency shared a little video for National STEM Day last week. It's in our highlights if you missed it.
Mhm.
But they put on a little video about all the different careers in STEM and how it's not just what you think, it's not just scientists and research,
Mm,
but there's so many other things that go into STEM and that go into especially the space industry, looking more at a focus of that. There's engineers, there's mechanics, there's all these different things, there's, farmers,
yeah.
there's, hundreds and hundreds of different jobs.
So they have this cool room that you can look into, and it's got all these computers and people working, and they're detecting space debris. And they're working with countries all over the world to say, hey, you're about to launch a rocket, but just letting you know there's space debris that we are concerned about that's going this speed, this fast in your direction. and they're doing awesome work, because unfortunately space debris from in the 1900s, when, you know, space was new and they were just sending stuff up there, has become a bit of a problem. And
Yeah.
as we get more sustainable, we're not going to make as much mess as we did back in the day,
Yeah,
like we
definitely.
are on Earth now. But you know, it happened, and Australia is doing great work in detecting and watching all this space debris and making sure that it's not going to cause any issues.
Yeah, definitely.
Yeah.
That's a really big thing. So, it's really good that is working on bringing this sort of awareness into the industry because, like Taylor said, you can't be what you can't see. If people don't know that these jobs exist and that these opportunities are there, then how are they meant to say, hey, that's what I want to be?
Yeah.
That was the case for me. It wasn't really something I considered seriously as a job pathway until, I went to USQ and experienced that and saw how much there was to offer in space at that time.
Yeah, definitely. Definitely. And especially in the schooling system at the moment, it's only been in the last 5 years that they've put in STEM classes in the government
Mm,
side. So, and even then, I don't think it's actually talked enough about the careers involved in Australia in those STEM
no.
careers. In those, yeah, it's
Yeah.
quite sad in the sense that it's going to be such a growing industry and they want the workforce there. But the people that are going to be walking to these workforces are not educated about enough. And it's not their
Yeah.
fault. It's not their fault at all. And as well as that, what Caitlin, you had the statistics about how many students felt they were just not smart enough to do it.
Okay, yeah, so I found this on, it was a summary that the Queensland government did on youth in STEM research that they conducted over 2018 and 2019, I'm pretty sure, or it was 2019 and 2020, I think some of these statistics were from, and they looked at the sort of young people, I think their age bracket was 12 to 25-year-olds across Australia, and they asked them a bunch of questions about STEM, obviously in school and outside of school, and inside of school found that lack of confidence was one of the most critical issues, with 37% of these students saying that they felt that they weren't smart enough to actually do STEM subjects in school, and another 46% saying that STEM subjects were just too hard for them, which is completely untrue. And I think that's something that Taylor and I really want to push
Yeah,
forward with this podcast as well, is that
yeah.
anyone can do STEM. Like STEM is, not just for,
Mm.
the brainiacs that spend 100 hours a week studying.
Yeah.
Anyone can do STEM, it's just about,
I
you
think
know,
that's so important as well, because when I left school, I did general maths. So I didn't do the engineering maths or the math methods. Yeah, specialist maths. And I am still walking into a physics degree because after I left school, I decided, you know what, I really want to do this. And I've worked over the past 2 years learning maths, even after I left school. And it was not impossible. It was not impossible at all. And even though it's hard, when it's hard, you know that means you're learning. It
yeah,
means you're actually learning something and you're challenging yourself.
and it makes you feel like so much better when you're at the end and you understand and you're like, oh, you know what, this feels so good that I
Yeah.
get this hard maths now. And then it doesn't really become that hard after then.
Yeah,
And it's
because
sort of
it's
like a,
just practice. Maths is
yeah.
really seriously just practice. And I wish I had told myself that earlier, but you know, everyone has to do it at their own pace. But now I'm in uni doing specialist maths and I absolutely love it. Whereas I was afraid in school, that same feeling like I'm not smart enough. I can't do what those other smart kids are doing. You know, it's me. Why would I be able to do that?
Yeah, and I think school really does like, breed this negative thinking about it as well.
Well, funny story, when I was in year 10 and we had to go in and pick our stage 1 and 2 classes, which is obviously what goes towards your ATAR in the NT, I said I want to do physics. And that's because I had a love for physics since I was a kid. And the careers teacher looked at me and said, I think you should reconsider that. Maybe you should pick something
Oh,
else. No joke. And I looked at her and went, no, that's what I want to do. And she went, okay, well, I'll put it down, but I think you should really reconsider because it's hard. And that made me more determined. I was like, I'm going into this physics class and I'm going to slay. And at the end of year 11, I got the achievement award, and it was the big award ceremony. And I remember getting up there, I was like looking for her in the crowd, and I saw her. I was like, that's right. You told me not to pick this class. You told me not to do it. And we had to get our photos taken. And another teacher said to me, oh my God, girl getting the physics award. Good job. That's so amazing to see. And for me, it was like I worked really hard, and it was purely to prove that teacher wrong. But, that's what happens when people tell you can't do it. You've got to take it, and you're going to be like, no, I can do it. I can do it, and I'm going to show you I can.
Yeah, definitely don't let other people say that you can't because of, something that's really huge, but definitely that just proves even more that, what you're saying about the school system, that it's just really not good. And I think it puts so
No.
much pressure on students to do well that a lot of them do feel like they're not good enough and they're not smart enough to do it. And, they do get like that anxiety and they are scared to do it.
Yeah,
Because
definitely.
it's so full on. They make it out like, oh, it's so hard and you have to work so hard to do it, and so they're branching away from that when it really.
Yeah. And I think especially, in the younger years when they do science classes, a lot of the fun is taken away from it. And it's
Yeah,
unfortunate because science, I believe that in the younger years, science shouldn't be a class where you're tested. Science should be a class where you get curious and you learn about the cool things in science. And then later on, you learn about those itty gritty bits, the stuff
yeah.
that's hard and you don't want to learn. So the other day, I did the moon quiz on our Instagram page to a group of the students at work. And they all got the questions wrong, which was awesome because when I
They were
told them
learning.
they were learning, but when I said to them, on Titan, you strap on wings and you can fly, they were like, what? That's so cool. So, yeah, I said to them, I'm sad that this isn't the stuff you guys get to be taught in school, because seeing their reactions about it and thinking, wow, that can actually happen on moons in our solar system, that's so weird. And when I was showing them photos of these moons, they're like, wow, moons can look like that. Because if you've
Yeah,
ever seen photos of Io and Europa and stuff, they look very different to the moon we know and see every night. And they were so interested and, and shocked. And it was awesome to see them learning and finding it interesting. And I went, this is the stuff that will spark people's interest in space, the cool things. And
yeah.
it's not like they're not learning, because it's true. You could strap on wings and fly on Titan.
Yeah, definitely. I think, yeah, we're all like humans are, naturally curious creatures. And, I really feel like in school, it's just like they don't nurture that through science. They don't try and help that. It's just, sort of test after test after test. And then, kids don't want to do it because it's too hard, or they think they're not good enough to do it because there's all the testing. And then, everyone, they just get brought down all the time in it.
Yeah, and it's, I think year
And I mean,
11 and 12, it's important to have, that itty gritty stuff to prepare for those higher studies. But in those younger years, I think my students were telling me they were learning about how to calculate how fast something can move in space. And I'm like, no kid is going to be interested in how fast an astronaut can move through space.
yeah,
It's not something they should be learning about either.
yeah,
When are they
definitely.
going to use that, and why would that spark any interest? Learn about the cool things in space, like galaxy and black holes and all the sci-fi sort of stuff, and then get into the itty gritty stuff. I don't know.
Yeah.
I think that's how I got interested, was talking about all that stuff with my dad. all
Yeah,
the cool stuff.
definitely.
And now I
Definitely.
enjoy the itty gritty stuff because it relates to the cool stuff.
Yeah, it's definitely a process, sort of going through it. But, no kid's gonna want to like go into a career that they hated in school. Like, if
Yeah,
you're sitting in the
exactly.
science class, you're like, oh, I just absolutely hate this, or you hate the maths class, then they're not going to be inspired to go into that as a career. And then, everyone complains about how there's not enough people in STEM careers. Well, how do you think they're going to get there when one, there's so little exposure to Australia as like, engagement in STEM as an industry,
Yeah,
and then, the school system's shocking.
yeah, no, definitely.
So yeah, I
Yeah,
will post a link to the study that we spoke about um, as well this week on our little slide. So if you want to check that out and read a bit more about that and the study that they conducted, and some of the statistics that they spoke about, which it's really quite interesting.
we can
I
completely
can
carry on this conversation to our next episode. That's fine. I don't want to wear any of our listeners out. So,
No, so should we have a look at
yeah.
some questions then, I guess?
So, we got a question about asking us how do they know how far Alpha Centauri is? And it's actually, there's a few ways that we can measure how far things are in space, and astronomers have gotten really good at it as well. But one of the main things that they do, especially with stars, is they do this thing called a parallax measurement. And so, when you put your hand or your finger or something in front of your eyes and you close one eye and then you close the other eye and your finger moves from side to side, they basically use that same principle to measure how far stars are away, except they measure the position of the star from one side of the sun, and then they measure the position of the star from the other side, and then they compare the two, and then they use trigonometry to calculate the distance. So it's basic trigonometry, really, in the end, but
Yeah,
it's and angles. They just use the angle of the Earth compared to the star moving, and they just basically draw a triangle, and they calculate that distance from that.
damn
Yeah,
triangles. It always comes back to the triangles.
it always comes back to the triangles. And when my students say to me, "What's even the point of trigonometry?" I'm like, "Trigonometry is everything." It's
Learn your trigonometry.
literally yeah. No,
It will
so
solve everything.
it solves absolutely everything, and it's actually um, how they first really started thinking about the Earth not being flat was they used shadows and trigonometry. Yeah, no joke.
Yes. So another question that we got was, do you believe there are other human-like life forms, and if so, what do they look like? Now that's
Mm.
really interesting. What was that show, Tally, you're watching on Netflix?
Oh, I think it was Alien Worlds or something on the
Yeah,
lines of that. Yeah,
yeah. Well, so about them, like, what would they look like? Obviously, their environment's going to impact them. The conditions of that planet that they live, it's going to impact them. So the Netflix show Alien Worlds or Alien Planets, what it's called, we'll find out the actual name and we'll put it on Instagram.
yeah,
Um, but yeah, it was really interesting. I watched a bit of it as well. It talked about, it theoretically looked at all these different places in the universe and showed, what life would look like on that planet.
but it was interesting to see, and it was actually astrobiologists that got involved
Yeah,
and made this TV series. So they put a lot of work into how things would evolve and how they might look like. And the last episode looks into an intelligent species, and it's very interesting their take on what an intelligent species might look like. So definitely recommend it. Yeah.
yeah, it's really interesting. Astrobiology is another career that's really starting to pick up now, which
Mm,
is something I hadn't even heard of until, a few years ago. But yeah, it's also really interesting as well, to definitely look into. But yeah, so as for other human-like life forms, I think there's definitely other life forms in the universe. Whether or not
yeah.
we'll ever find them is completely different. I just think the universe is too big to
And
not for us to just be
Yeah.
here.
And scientists still really don't understand the concept of intelligence. Where does it come from? How does it form? And what makes a species intelligent? So,
Yeah.
you know, that's part of the Fermi paradox is like you've got life and then you've got intelligent life. And where that intelligent life is on that intelligence scale really is what you define as intelligence.
But yeah, definitely if you're interested in looking more into that and into, you know, what life could look like, definitely check out that Netflix series. But yeah, it was really interesting, and it was all, you know, obviously Taylor said they worked with the astrobiologist, so it's all, you know, factual and,
Yeah,
you
and
know,
they come back
based
and they
off.
compare to the research they find on Earth as well. It's really cool.
Yeah,
Yeah.
it's definitely really interesting. So definitely, if that's something that you're interested in looking into, or, you know, having a good little watch of that. So
Mm.
yeah, I think we are getting a little over time now. Been long. We've talked about quite enough this time. I think that's the end of this episode. Thank you so much if you listened to all of
Thank
this.
you, everyone. Make sure to go follow our Instagram page if you want to see our awesome posts, and they will normally relate to our episodes. So definitely recommend giving us a follow. And like we've said before, we're real cool. So just give us a follow
Yeah,
anyway.
definitely. And if you have any questions, we put up on our Instagram story every week where you can ask us questions. But if you missed that, or if you just have a question that you really want to know, feel free to DM us or email us or just comment on any of our posts, and we put that in our little bucket of questions that we answer each week.
Right.
Hopefully, my editing will be good this week. The editing gods will be
We'll
with
be
me.
one. We'll be one. And
I will be
hopefully
one with the
YouTube
dark
likes
energy.
us and it uploads nice
We're
and
really
quickly.
sorry that YouTube is taking so long
Mm.
to upload. We upload it literally the night before. We upload it on Sunday night, and we get on at 7 o'clock, you know, in the morning to go see, and it's like 20% done uploading,
It's
and we're
very,
like,
very rude. It is.
so
It's
we don't
rude.
really know what to do about that. It's not our
Hmm.
fault. We're not doing it on purpose. We're very sorry.
Yeah,
We're
but it
getting there.
gets there. It slowly gets there. So that's all
So
that matters.
hopefully this week YouTube will be up at the same time the podcast is up. Um, If not, it shouldn't be too much longer until we can figure out how to fix YouTube's slowness. Honestly, don't know how YouTubers do it.
Yeah, it's tough life.
YouTube, how are we meant to make money if you don't
Exactly.
upload us? So rude.
Exactly. And we
Anyway,
need,
yeah.
yeah, we need
We
that
need
1,000.
1,000 subscribers. We can't get it because our YouTube videos don't upload. They're
Oh,
ripping us
God.
off. They're ripping us
Honestly,
off.
honestly. Alrighty. Thank you,
And we'll see you in next week's episode.